Hi, my name is Kenneth. I am a technology evangelist with Rackspace, and you can follow along this presentation on Twitter and tweet as much as you want. So one of the reasons I'm here is one of the most frequent questions I get as I talk to customers is what type of application should I be running on a cloud platform such as OpenStack or AWS, and what should I be running on a more traditional infrastructure such as bare metal or VMware? So because I get that question so much, I do a little talk. I call it the tale of two workloads. So what do I mean when I say there's a tale of two workloads? Essentially, there's a pretty truism, I guess, for deciding what workload you run on what infrastructure. And that truism is workload dictates architecture. And if you have the incorrect architecture running a particular workload, that workload will likely fail. So what are those two workloads? Well, one is what I call a traditional workload, and it has very traditional design principles behind it. So you're probably all familiar with this idea of the kind of a single monolithic architecture for an application. So even in a multi-tier application, think in terms of something like Oracle, right, that sits on one server. And if you want that server to do more, you basically have to add more memory or more drives or CPU. And when that server runs out of memory resources, you have to add another one, but then you're basically adding a second instance of that database. Same thing for things like middleware and web servers. Also, these services that run on these applications, these traditional architectures, tend to be stateful. So if the server fails, even you're able to spin up the application somewhere else, basically all the clients tend to lose connection to that particular service, and you have to start over again. And finally, a third characteristic of this traditional architecture is that it's operator focused. So for example, if you're a VMware administrator, right, I've never talked to a VMware administrator who said, I'm comfortable handing over my vSphere web client to an end user or developer and saying, you provision the resources yourself. And so because of that traditional infrastructure and the requirements for it, right, that application needs to have a very resilient type of infrastructure underneath it, because again, because of the statefulness and the monolithic architecture, right, if the server under the application failed and it doesn't recover, then basically you're hosed. So there's been a lot of ways to kind of get around that, right, to deal with that by either having very redundant type of hardware, things that you see such as FlexPod or vBlock. And obviously, in the software side, many people run these traditional workloads, again, think Oracle and Exchange, on infrastructure like VMware or vSphere, where if the infrastructure were to fail, the assumption is the VMs would just restart automatically on another server using shared storage, and the application continues running on. So that's your traditional infrastructure that most people are very familiar with. But there's another type of application, probably 10% of the enterprise today, but growing very quickly to perhaps 50, and someday even maybe 80, 90% of the enterprise. And those are what we call cloud native apps. So think again in terms of something like Twitter or Facebook, or in a bank, more like a kind of a mobile application, where the expectation is just servicing thousands and hundreds of thousands of users very quickly. So in that cloud native type of application, the design principles are completely different for the architecture. So see here, for example, it assumes a distributed architecture. So in other words, the application doesn't actually reside necessarily on one server, but across multiple servers. So a single database might actually be chunked and spread across multiple devices, so that if some of those services went down, you would continue running. As well, there's that concept of stateless servers, where again, you may have multiple instances of the same application or service running somewhere, and if clients are talking to one part of that service fail underneath it, it would automatically reroute itself to the other parts of the service. And finally, cloud-native applications are very developer-focused. So again, you hear a lot of talk about cloud APIs, and the concept behind that is every single service that's available to that cloud infrastructure is available for the user to access and utilize. So when a developer, for example, going to OpenStack or AWS, wants some resources such as servers or storage, they no longer have to talk to an admin. They basically have the ability to spin it up themselves and tear it down when they're no longer necessary. So one of the interesting things, though, about that type of cloud-native application and infrastructure that it runs on, typically a cloud platform like OpenStack, is that the assumption is the infrastructure is fragile. And not only is it fragile, but that when it breaks, the infrastructure doesn't recover by itself, typically. So you see here, for example, that when it fails, when a compute node fails, the VMs don't restart on another compute node. The services just, the instances go down, but the services stay up. And I'll talk more about that in a minute. So inevitably, I get this question from your traditional VMware admin, for example. What is wrong with cloud that it can't even do a very basic task like doing an automatic failover of VMs? And the reason I give is that actually by design it doesn't do that, because in the cloud, what we care about is architecting for rapid scale. So whereas in a traditional virtualized or bare metal infrastructure, it's all about resiliency for that one application or two applications. In the cloud, we want to grow at rapid scale. But another truism is that when you scale rapidly, failure is inevitable. Your storage is going to fail. The servers will fail. The VMs won't restart. The software will break. So you just assume that the infrastructure is going to fail underneath and it won't recover properly. And so what you do is you need to design for that level of failure. And you do that in a number of ways. And I call this basically resiliency in depth. So there are multiple layers to it. One is, one of the truisms, you need to let the application handle its own resiliency, right, instead of the infrastructure. Just assume these are commodity boxes that will never recover by itself. Let the application replicate data to other nodes and let it reroute itself to those, the application to reroute itself to other node client requests as well to those other nodes. Build loosely coupled distributed systems. So again, this idea that the application doesn't sit on one server, but across multiple servers, so that it can scale rapidly. Because when everything has to go through one server, that's where your bottleneck is. So a typical example is that in the VMware world, when you use vCenter, the vCenter manager server can only accept 8 requests at any one time. So you can't. So if you try to scale to thousands of servers in minutes, your vCenter server actually becomes a bottleneck because it's not a distributed architecture. And then focus on scaling horizontally. Again, instead of trying to upgrade your one server, just create multiple smaller instances that run that same application. So that when you need to burst up, right, instead of upgrading a server, you maybe spin up from 100 servers to 1,000 servers and then tear them down when you don't need them anymore. And then all this comes to this idea of choosing cattle over pets. So what I mean by that is, in the traditional bare metal or virtualized infrastructure world, all the VMs or servers are considered, you treat them like pets. You take care of them, you know them by name, you feed them well. When they have a problem, you spend hours calling support to try to fix them, right? Because the applications all run on that server, or a couple of servers, and if those servers don't recover, then you have problems. But in the cloud world, you treat them like cattle, which basically means that these are all disposable. So when you have cloud instances that have problems, you don't spend a lot of time fixing them. You basically shoot them and recreate those instances somewhere else. So a good example is in Netflix, which is a canonical example of an application or a company that runs on cloud. The average lifespan of their VMs are 36 hours. And part of the reason for that is, again, when there's a problem with an instance, they just shoot it and move on. The other thing is they've recognized that when you run applications in a large-scale environment, there's always some number of VMs that have issues, like memory leaks. And rather than trying to address them at scale, basically you just blow them away and start over again. So you're always starting every 36 hours with a fresh set of new cloud instances to run on. And perhaps the most important thing that often people overlook when they talk about how do I move from a traditional workload to a cloud-native workload is it's all about automation and it's all about cultural change. In other words, I can have all the technology that would be possible to use cloud-native applications, but if you don't automate it and if you don't have a culture change where your developers are working hand in hand with your operations team, you ultimately fail in being able to run a true cloud infrastructure. So thank you for your time, and I look forward to speaking with all of you again at some other point. Thank you.